So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass code at the side. So today's problem is longest subarray with sum k. That is, the problem statement is actually clear from the heading itself that you have to find the subarray that is contiguous part of array whose sum is k. The sum of its elements should be k, and it should be of longest length. Longest length. Okay. Now, whenever we have seen whenever there is a question of subarray, brute force say make all the subarrays. That is, brute force will be something like for I going from 0 to n minus 1, for j going from I to n minus 1, sum equals to 0, for k going from I to j, this is my particular subarray, sum plus equals to a of k. This will give me the sum of the subarray after this loop. Now, after this, what will I do? If sum equals to k, or I can say it is x here, right? Sum equals to k. K is the given value to me. Here k is 15, right? Here k is 15. If sum equals to k, then you can initialize your answer as outside the loop, and you can say answer equals to maximum of answer comma current length. And what is the current length? The length of the subarray, that is from I to j, that is j minus I, right? And at last return your answer, right? So what is it doing? These two loops are making all the subarrays, calculating sum, and then this formality of checking it if it is a correct sum or not. Okay, so this will take a time complexity of n square, and this will take a time complexity of n. Total time complexity gets O of n cube, and the space complexity is O of 1, right? Is O of 1. That is, for this particular question, if you see what are the sum of subarrays, so you can see, let me copy it down. Yeah, so what will happen? It will start from here. Sorry, it will start from here, right? Your answer is currently 0, right? Your I will start from here. What will happen? J will be here. That is first case. I and J both are here. Sum is 0, right? Then J will come here. I and J are one distance apart. Sum equals to, sorry, our sum is 10 here, which is not equals to 15. Then sum is equals to 15 for 10 and 5, right? Sum 10 and 5, sum gives 15. If it is so, J minus I plus 1 also, J minus I plus 1, right? Answer will change to 2, right? Then for the third value, it will change to 17. Sum equals to 17. Not possible. Sum equals to, j comes here, sum equals 17 plus 7, that is 24, right? No. Sum equals to 25. No. Sum equals to 15 when j comes on the last element. Again, sum equals to 15. That means the whole array is giving me the sum of 15, which is my required case. So answer changes to j minus I plus 1. That is 0, 1, 2, 3, 4, 5. 5 minus 0 plus 1. That is 6. 6. Answer changes to 6. Then your I will shift to this one, and all the other loops will go on. Your next final answer will be 6. That is for sure, right? Now, can I, like, this is n cube, which is highly incompetent, right? I need to improve it. What will I do? Okay, brute force, or I can say it efficient one. What will I do? Instead of using this loop for sum, what will I do? I will just initialize my sum equals to 0 here, and then I will remove all this part and write a new part inside it. That is, it will look something like for I going from 0 to n minus 1, sum equals to 0. You will initialize your answer equals to 0 here for j going from 0 to n minus 1, right? sum plus equals to arrj. So no, not from 0 to n minus 1, it will be I to n minus 1, I to n minus 1, right? Sum plus equals to arrj. Now if sum equals to k, answer equals to maximum of answer and comma current length. What is current length? J minus I plus 1, right? J minus I plus 1. At last return your answer as your final answer, right? This is n square, and from here O of n square is the time complexity and O of 1 is the space complexity. Sorted, right? But we are not here for the efficient and the brute force one. We are here for the optimized one because that requires your actual algorithm, right? Okay, so let us move there. So this is my array, right? This is my test cases. Now, how to solve it using optimized version? We have already seen O of n cube, O of n square. Obviously, we need something shorter than this, right? So what will I do? I will see what are the subarray sum. So 10, 15, 17, 24 and so on, right? Then 5, 7, 14 and so on. Then 2, 9 and so on. Then 7 and so on. 1 and so on. Minus 10, right? Now, how to get an idea. Let me remove all these subarray sums, right? How to remove and get an idea of optimized approach. What is a subarray sum? What is a subarray sum? Subarray sum of all elements of that particular subarray, sum of all elements of that array, correct? Sum of all elements of that array. That means sum of a contiguous part of array, sum of a contiguous part of array, contiguous part of array. Now, if I say my sum equals to 0 here, and I am trying to get all the sums up till I, right? Something like this. Let us make an array. Current sum is 10, including this element, right? 10 plus 5, 15. 15 plus 2, 17. 17 plus 7, 24. 24 plus 1, 25. 25 minus 10, 15, right? Right. Okay. So these are the sums, right? Now, tell me guys, tell me if this is 15, if this is 15, right? And this is 25, and this is 25. That means these two elements give me a sum of 15, right? These elements give me a sum of 25, this gives me a sum of 15. Can I say by simple mathematics that these three elements are giving me a sum of 25 minus 15? Or can I say that these three elements, that is 17, that is 2, 7 and 1 are giving me a sum of 25? Yes, because if these are 15 and this total is 25, that means this length is contributing 10. This length is contributing 10, right? Okay, so that is my approach. What will I do? I will make a map of type int to int. Let us name it np. Now, simple. Initialize the sum equals to 0. Now, for I equals to 0 till n minus 1, do the following. First, increment your sum. So, sum plus equals to arri, right? Now, if mp dot find sum is equals to mp dot end, that means the sum doesn't exist in mp, only then you replace it, because we need the longest length, so we need to take the farthest point, right? So mp of sum equals to current index. What does it tell? That at the index I we found this sum, right? Now what to do? Now if mp dot find sum minus k is not equals to mp dot end, right? So what I'm trying to say, suppose if k equals to 10 here, if k equals to 10 here, then if I find 25 minus 10, that is equal to 15. The map contains 15 here, right? The map contains 15 here. 0, 1, 2, 3, 4. Map contains 15 with the corresponding value of 1 and 25 with the corresponding value of 4, right? That means The length of the array which is giving me sum of 10 is 7, this length, right? 3, that is 4 minus 1. As simple as that, right? If mp dot find sum minus k is not equals to mp dot end, answer equals to maximum of current answer and I minus mp of sum minus k, right? Yeah. Else if my current sum is equals to k, that means the whole length up till now is my answer. So answer equals to I plus 1, because I is zero base indexing, so I need I plus 1, right? Done. And then return your answer. As simple as that. So what we're trying to do, we're trying to take a reference from here. At the sum 25, we need to find 25 minus 10. If this exists, then update your answer. Otherwise, update your MP and move on. Right? So it is taking only one traversal, guys. So time complexity is O of n and space complexity is O of n. Why O of n? Because of the map. Right? Okay. So I hope this is clear to you and we are free to move to the coding section. So here we are on the coding section, guys. Let us start without wasting any kind of time. What will I do? I will say unordered map of type int to int, name it as MP. Int answer equals to 0, right? And sum equals to 0. Now that we have declared the variables, I would request you to please subscribe to the channel before moving on. Now, for int I going from 0, I less than arr.size minus 1, or you can take it size elsewhere and use that also. I plus plus, not minus 1 here. Yeah. Now, first thing is to increment your sum. So sum plus equals to arri. Now, if mp dot find sum is equals to n, that is mp does not contain your sum, then mp of sum equals to current index. That is, at this particular index my sum was this, which is sum, right? Now, if mp dot find sum minus k is not equals to mp dot end, that is, we have found a value with sum minus k, that means the value between those particular index is equal to the required sum, then answer equals to maximum of answer comma I minus mp of sum minus k. Else if sum equals to k, then also we are sorted, then answer equals to maximum of answer equals to k, not maximum, it is gonna convert every time. Now return your answer. Right, let us try to compile and run it, guys. Hope it will work fine. Oh, it is giving an error. Let me see. Some answer equals to I, sorry, answer equals to I, current I plus 1. Yeah, let us try to compile and run it. It is working fine. Let us try to submit it. It should run fine if I am correct. It is working and getting accepted. So thank you for watching. Hope you liked it. Please make sure to like and subscribe to the channel. Thank you. Have a nice day.